We are now going to take a tour of the Solar1 Mark I. This printer was designed and built by myself and is the printer we will be using for this lesson. Let's take a closer look at its components and features. The printer is constructed of extruded aluminum. I choose this because it is a low-cost and versatile construction material that is both strong and lightweight. This material is also known as 80/20 and is a favorite for the DIY CNC designs. 80/20 is not the only material that printers can be constructed out of. In the last lesson, we saw some different designs that utilize steel, plastic, and even wood. This is the build platform. It is the flat surface to which the print will adhere to. This one is 300 millimeters square, so the footprint of the objects are limited to this size. This build platform is part of the y-axis, which means the entire platform moves along that axis. The y-axis is driven by the rear y-axis stepper motor. Below the build platform is a heater pad. This pad raises the temperature of the build platform and helps prevent the warping of prints. We will talk about warping in detail in an upcoming lesson. This is the extruder assembly. It works exactly like the extruder assembly I explained in the first lesson. This is the drive gear. It is driven by the drive motor here. The filament here feeds down into the extruder assembly, between the drive gear and the idler bearing, and down to the heater core where it comes to its melting temperature, and it gets forced out of this nozzle. The entire extruder assembly moves along the x-axis using these rods and V-groove bearings like a train on tracks. It is driven along this belt by this stepper motor here. The z-axis is made by moving the entire x-axis up and down. The z-axis rides along the V-groove bearings on each side of the printer. The z-axis is driven by two stepper motors on each side of the top of the printer. It uses two threaded rods, known as lead screws, to move the axis. Lead screws are preferable over belts for the z-axis because they offer much higher precision. A quarter turn of the motor only moves the z-axis assembly 100 microns, or 0.1 millimeter. Let's talk about limit switches. What exactly are limit switches and what do they do? Well, the printer doesn't actually know where each moving part is at all times. The machine has to trust that when the computer tells it to move a certain distance, it does. Luckily, there are components that help the machine find its starting points. These are known as limit switches. Limit switches are components that will trigger a signal when one of the moving parts reaches its home position. This is known as homing. When the printer reaches its home position, it can then assure that when it moves the x-axis 150 millimeters to the right and the y-axis forward, it will be right in the center of the build platform. Limit switches can be mechanical switches with a lever or button that get pressed when the axis reaches its home. Limit switches can also be of an optical design. The idea here is that there is a light beam that travels between 2 points. When an object enters between those 2 points, it cuts the light beam and sends a signal to the computer. The advantage here is that the parts actually do not have to touch to activate the switch and reduces wear and tear on the machine. Here are the limit switches on this printer. The limit switch for the x-axis is mounted on the left of the x-axis assembly. It is triggered by the small tab mounted on the extruder assembly. The y-axis limit switch is mounted on the rear of the machine, near the y-axis motor. It is triggered by the tab mounted at the edge of the build platform. The z-axis limit switch is mounted on the side of the printer and is triggered by the tab here mounted below the x-axis motor mount. The brains and interface between the computer and the printer is the microcontroller. The microcontroller is a small computer that drives the signals to the motors and the extruders. It also receives input from the limit switches and the temperature sensors and feeds that information back to your computer's printer console software. This controller is a prototype and is in active development.